Is that our answer? We're done? We're finished sketching? No? All we've done is graphed the log base 3 function. Now we need to account for all the things that are happening in here. So let's talk about the transformations. Does anyone want me to stop, give you a second? Are y'all hanging in? Hang in there? Okay. So what are the transformations that we will have for this blue graph to get to our final picture? So where do we start there? The -1 inside with the x. That comes first. What does a -1 inside the function do? To the right one. So I'm going to take this blue curve, I'm going to move it to the right one. Okay? What's next? +2 or the minus? The minus comes next. Because the order of operation, this is like a multiplication out here. This is addition. This would happen first. So what does a negative sitting in front of the function do? Flips it over what? X-axis. And then the 2 right here, up 2. So to get a graph of this function, we're going to take that blue, we're going to move every point to the right one, we're going to flip that point over the x-axis, and we're going to move it up 2. Right 1, flip over x-axis, up 2. Y'all ready to see that happen? Okay, I'll do this. My final answer here will be in green. So we're going to, let me just pick a point here. Here's one. See that point right there? Move it to the right one. When I flip that over the x-axis, does it move? No, because it's on the x-axis. And then what? Up 2. Okay, there. Take this point right here to the right 2, or right 1, sorry, right 1. Flip it over the x-axis. Where's it going to go? Right there, right? So that point gets flipped over the x-axis like that. Understand? The reflection? Yes or no? Yeah. Okay. And then from there, where? Up 2. So it's right there, isn't it? Weird, huh? It's a little bit below. It's actually, because it started here, right? Went to the right one, flipped over the x-axis, up 1, or up 2. So I'm actually right there. That blue is above it. How about this point? Right 1, flip over the x-axis. How high is that off the x-axis, by the way? It was 2, right? So it's going to flip over here like this and become here, and then up 2. So where's it going to land? At the x-axis. Is that enough for you to see what it does? How about we take this point right here? Move it to the right 1. What about here? Flip over the x-axis. About here, and then what? Up 2. Somewhere around there. Can you all see it or not? Yeah. Okay, it's going to look like this. All right. Now, I have a vertical asymptote, don't I? Has that vertical asymptote moved? It was here at 0, right? X is 0. The whole graph moved to the right 1, didn't it? So does the vertical. It moves to the right 1. So what's happening here is your vertical is actually up on top now, like this. But it's been moved to the right 1. So that green graph is your final picture. What do y'all think? Think you can handle one of those on a test? No? Look, very seldom in the further math classes do you actually have to graph a logarithmic function by hand. I mean, a lot of times what we're more interested in a class beyond this one is how is that function behaving. So like I could come here and say, what's the domain? 1 to infinity, right? Parentheses. What's the range? Well, it's still everything, right? Is this function increasing or decreasing? It's decreasing. Those are the types of things that we need to know in like a calculus class, all right? What's happening as x approaches 1? So what happens to the function as x gets closer to 1? The function's taking off to infinity, right? As opposed to the blue curve where it was going this way, we need to know it's going this way instead. So a lot of times it's not so much getting every point perfectly pinpointed where it's supposed to be, just more of the behavior of the function and what it's doing. Okay, we good? All right. Properties, we got those. Excellent. Doing good. Now I'm going to give you the next formula now, even though it doesn't come until the next section. And this is a really important formula. It's called the change of base formula. And this is just a very important formula, so I'll put stars on each end. And here's what this formula says. So we're stepping away from the graphing, all right? We just did that one quick graphing thing, and now we're moving on. Let's say somebody gives you a logarithm, and they give you that the base is a, they give you something like x. So next to this, I'll give you an example of what I mean. Let's say someone says log base 3 of 5. What this was saying was, in this particular problem, what, 3 to what power is 5? And we don't know what that is, right? 3 to what power is 5? We can't tell. We don't have a key on our calculator that allows us to do this, right? But according to this formula, log base a of x is equal to the natural log of x divided by the natural log of a. And that's the formula. And so this, according to the formula, really turns into what? Natural log of 5 over natural log of 3. And when I say over, I mean divided by. So I'd like everyone to get their calculators out and see if you can tell me what log base 3 of 5 is. And this is where your use of parentheses and what type of calculator you have matters, right? See if I can get this one to work out right. Anybody get 1.4649 something? Okay, so this should be approximately equal to 1.46, I'll say 5.
I did not get that.
You did not?
No.
So let's see how you typed it in. Use natural log and then log. They got to both be natural log or both be log.
Oh.
ln over ln. You did ln over log.
Yeah, that's what I thought it was. That's what I heard first time.
Yep. Anyone else need help?
So do I just put ln?
Yep, natural log 5,
I have like
close parentheses, divided by natural log 3, close parentheses.
I just didn't know if the parentheses like.
That's very important because when you put the parentheses, when you type in on your calculator, natural log parentheses 5 divided by natural log parentheses 3, this 5 belongs to that natural log, this 3 belongs to that natural log. The division separates them. So everyone got that okay? So that's it. I mean, this is really a nice thing because what we're saying here is this. If you take 3 and raise it to this number, 1.465, it should be approximately 5. So someone double check that. On your calculator, take 3, raise it to 1.465. I bet you it's really close to 5.
5.0014.
Okay, so and depending on how many decimal points you go here, you'll get closer to 5. So that formula alone, right there, allows us to solve any base log. Do you all agree? And so there's no more craziness here, right? I mean, there's no more. I hope there's no more craziness. Okay. So let's try some problems here. So let's solve some problems. How would we have done that problem if that was the quiz problem today? How would we have tried to do that problem? You try and make the bases the same, right? And so you would hope that maybe you could rewrite the 4 and the 15 as the same base. Can you do it, though? No, you can't. So starting today's class, we would have been stuck. We wouldn't have been able to do this, right? But there's got to be some power I can raise 4 to get 15, right? Because if I square 4, I get 16. There's got to be some number I can get in there to do it, right? So now we're going to use what we've learned today. All right. Convert this to log form. Go to log form with this. What is this in log form? Log base 4 of 15 equals 2x plus 3. Do you see that you've released the x from the exponent now? So all you have to do is solve for x. You know, subtract 3, divide by 2, right? But you've got to figure out what this side is. But what's log base 4 of 15? According to the change of base formula, I can do that on my calculator, can't I? That's really natural log of 15 divided by natural log of 4. And then the other side I'm not going to touch yet. So on your calculator, please, natural log of 15 divided by natural log of 4. 1.9534. Now, I want you to go at least 4 decimal places. If you want to go further, you can. What's wrong? Okay. Anyone else get 1.9534? Yes? Okay, so let's see. See how you typed it in. You got to close that parenthesis after the 15. Every time you're done with the natural log, close it. Everyone else got that? That's the left-hand side. Equals 2x plus 3. This is a linear equation, isn't it? So go ahead and subtract 3. So take 1.9534, subtract 3 from it.
Negative
0.0465 equals 2x. And then divide both sides by 2. And what would you get? Negative point what? 5.233. So your solution is negative 0.5233. So going back, the original problem was 4 to the 2x plus 3 equals 15, right? That's what our problem was. I'm saying that if you take this number, so I'll take it on my calculator. I'm going to take 0.5233, actually negative 0.5233. I'm going to plug it in right here. I'm going to multiply that times 2. I'm going to add 3 to that. And then I'm going to raise 4 to that power. And I got 14.56, which is off, isn't it?
Not when you round it up.
But not when I round up, but I would like to be closer than that. So we can see that just rounding 4 decimal places made a lot of error, didn't it? I mean, I know I'm getting close to the right answer, but even 4 decimal places, that created way too much rounding error in the problem. But we're right. I mean, this would be correct on a test. Again, I'm looking for the method more than I am anything else. So as long as we all use the same convention, we all round about 4 or 5 decimal places, we'll all have similar answers. All right? Okay. Now I'm curious. I'm just wondering how you would deal with this. There's no promises that this is going to work out. But let's take today's quiz question, which was 3 to the x squared minus 7 equals 27 to the 2x, right? We could do this. I did it, right? After the quiz, I showed you how. Can you convert that to log form? You can? What's the base? Why not 27? Could it be 27 also?
Just don't break it down. Well, would you break it down first and then
Let's try not to break it down. Let's try not to break down the 27 right now.
would you have logs on both sides?
Let's see. This is more of we're thinking. Could I do this? Log base 3? Is that okay?
This would be the most simple, the 27, so we'll break it down. You don't have
So what goes in here? What goes here? What goes in the other side? 27 to the 2x, and then over here would be what? X squared minus 7. Do you all agree that that would be the log form of that? Yeah? But how do we do this? Right? Like how do we figure out, like on the problem I just gave you, this was like log base, what was it, 515 or something like that, and we could use our calculator? We can't use our calculator here because that's an x and we don't know what that is, right? So we could keep going, but there's a property that I need to show you, and that'll be next class. What we'll see next class is that anytime you have a log, and you have a base, and you have something, and you have a power here, guess what? This power actually you can actually pull the power out in front of the log. That's beyond today's class, though. And so what happens is that this just turns into log base 3 of 27. 3 to what power is 27? 3, right? So this whole thing turns into a 3, and out front you had a 2x. So it becomes 6x equals x squared minus 7, and that's exactly what you had to do on the test. But that's beyond today's class. That's what next class will come in. We're going to be talking about properties of logs and solving all types of crazy log equations. It's going to get pretty nasty, all right? But so the point was here is that we can almost use what we learned today, but not quite. Just taking a look at the homework real quick to see, make sure there's nothing in here. Did the packet of papers get around to everyone? No, I didn't. Okay. Let's do something we haven't done in a long time. Let's sign in. Yeah. And just sign in the last column here. All right? Just sign the last one only. So I'm gonna cut you loose on your homework to let you go ahead and try and do what you can. So we're going to end class a little bit early, about 10 minutes early. And what I'll do is I'll promise you on the next class, we'll start class with any questions, because I think you'll probably have a couple of questions on the homework. All right? So we'll start class maybe first 10, 15 minutes with questions, and then we'll proceed into the properties of logarithms, 6.5. And that's, I guess, it for the day, right? Have a good day.
This one's good.